Hello everybody, how are you doing? Nice to see you today. And today we continue our work on determinants of the matrices. So next our topic is properties of determinants. So I want to write down here property of the determinants. Properties of determinants. Determinants. So the first one, property, determinant of the matrix A equal to determinant of the transposed matrix. Okay. Second one, property. If one of the row or column has all elements zeros, all zero elements, determinants of the matrix is 0, then determinant of the matrix A equals 0. For example here, example yeah. Matrix A equal 1 2 3 10 5 0 0 0 0 0 10 11 100 7 8 5 0 10 1000 10 5 5 6 7 8, and you have a job to calculate determinant of such matrix. If you identify one of the row as a 0, you can put down the answer. The determinant of such matrix is a 0. So next one, property if matrix has 2 columns, at least 2 columns, or rows, to equal columns or rows, the determinant of such matrix equals 0. So we have here also one example. I give you a very easy matrix. A equal, for example, 2 3 2 3. You can see that these row, the first row is equal to the second row. Determinant of these matrix, you know that we can use cross rule. It is 2 times 3 elements which are located at the principal diagonal. 2 times 3 minus 3 times 2, and it is 0. So you can compare two rows or two columns, and if you notice that two of them are equal, the similar kind of, you can say that the determinant of such matrix is 0. You shouldn't calculate it. I shouldn't calculate the determinant. Two rows or two columns of any matrix, where matrix are proportional to each other. Determinant of such matrix is 0. Okay, here I give just one example here. For example, example here. If matrix A it is the matrix, the entries of matrix, for example, 1 2 3 2 5 10, for example, and 4 10 20. So you can notice here, I use here the other ink, for example red one. You can notice that the row 2 and the row 3, you can express row 3 as a row 2 times 2. So it means that the A31 equal A21 by 2, the A32 equal A22 by 2 times 2, and 20, it is 10 times 2. So you can see that the row 3 you can express is proportional to the row 2 with factor 2. Since that this determinant of this matrix, I use the same red ink, determinant of the A matrix equals 0. You can check on your own that determinant of A equals 0, but how you can believe me and use this rule to calculate determinants of the matrices. What else? Next one rule, next one property, the fifth one property here. For example, A and B, they are given matrices, this is they are square matrices with the same size, and they are square. So determinant A times B matrix equal determinant A times determinant B. Okay, this is the rule. By the way, I can notice here, don't mess our product with summation, because sum of the matrix, determinant of the sum of the matrices A plus B is not equal to determinant A plus determinant B. So this is the very important thing. Don't mess up these two operations. In the very common situation. Next one, property. So let A is a given matrix. Is a given matrix. Matrix. And here you have 6 times 6.1 rule. Determinant of the A matrix equal determinant of the matrix. I denote it like A matrix Ri plus minus Rj matrix. What does it mean? So if you take away from elements of the matrix of the row I, element by element of the row J, you'll have the same determinant. And 6.2 determinant A equal determinant A column I plus minus column J. So this is 6.2 is this very similar, closed, similar states the same as a point as a 6.1, but about columns. So if you take elements of the away or add to elements or entries of the matrix which are located at the column 1I elements of the column J, determinant this of such matrix doesn't change. 6.3 here. Determinant of the matrix A equal lambda times да. And 6.3. For example, you want to multiply all elements which are located at the, for example, row I. It doesn't matter which is row here, and lambda is not 0 here. It's a number, but not 0. This determinant of such matrix equal lambda determinant matrix A, and this rule works as well as for column. So you can multiply by lambda either row or column. For here, determinant A lambda column I equal lambda determinant A. Lambda is still non-zero element. Ri and Rg, see Ri in Ci, there are rows, row or column, either row or column. I row or I column. Okay, now an example. By the way, we'll check how this rule, the rule 6 works. I think that these three, the 6 rule or property, not rule, property, one of the most important for if you want to facilitate your calculation, determinant calculation. And firstly, I give you an example. One, for example. For example, you have matrix A equal 2 by 2 matrix, if you don't mind. 2, 3, 4, 1. Let's calculate determinant of this matrix. Determinant of the matrix A, and we have 2, 3, 4, 1, and we have 2 times 1 minus 3 times 4, it is 2 minus 12, and it is minus 10. Let's calculate determinant of the matrix A, then we add to the row 1 row 2, and row 2 we keep still as at the given matrix. What do I mean R1 plus R2? I mean that the first element under R1 equal row 1 plus row 2, 2 plus 4, 3 plus 1, and here we have 4 and 1, and it is, I add to the elements of the row 1 elements of the row 2. I have 6, 3 plus 1, 4, and I have here still 4 and 1. And determinant of this matrix is 6 times 1 minus 4 times 4. And we have 6 minus 16, and it is minus 10. So you can notice then if we add row to row, we have the same determinant as we had, as well as the first one, the given matrix. What else we can do? For example, I want to calculate determinant A when I multiply row 1 by, for example, 3. It's my dream. I have still 2 times 3, 3 times 3, and here I have 4 and 1 still. And we have here 6, 9, 4, 1. If I calculate the determinant of this matrix, I have 6 times 1 minus 4 times 9. Since that I have 6 minus 36, and it is minus 30. You can notice that determinant of this matrix equal determinant of the matrix A, but I have to multiply this determinant by 3, exactly as it was stated by the property of the matrix. Now we have a question: why should we know these properties of the determinants? These properties facilitate the calculation of the determinants.